Welcome to this series of videos on data engineering. In the last session, we saw how we can submit a job uh, for machine learning pipeline. There we only completed a part of the pipeline where we just summarized the data and found out what are the missing values. So now we'll complete the rest of the pipeline. So as we mentioned that we are not going to get into more detailed pre-processing like finding out outliers or finding out collinearity, okay, or a high cardinality values. We'll ignore that because our objective is not to build a very strong or very accurate model. Our objective is to see how a model is created in Azure Machine Learning or a pipeline is created in Azure Machine Learning Studio and how is that deployed in a production environment. So we will start with the cleaning the data. So we'll just search for clean missing data. Now normally it's difficult to memorize these components. Over a period of time with experience, people get used to the names of the component. Otherwise, you just have to try out some of these names and figure out which component is helping to build that. So we'll just take this clean missing data, and we've already seen what are the missing data. If we go back to our job out, because here we won't know what are the missing values because this is a draft. Okay, so if you know that which is missing values, you have to go back to the job. Just say confirm. I didn't save the last one. And here only I will see what are the missing values. So we saw there are missing values for working class, then occupation, and then native country. You need to remember this working class, occupation, and native country, because in the designer, you will not have that information because these are draft. So we'll connect this output, not connect this output because this is a summary data. We need to connect the real data. And you see here a small orange exclamation. This is an indication that the node is not yet configured. You double click on this and a window opens, and this is the place where you have to configure the node. Now we have to say which columns we want to treat for the missing values. And we know working class and then occupation, and the third one was native country. So these are the ones that we want to do, clean up. Now, what do we want to do? We want to, so these are the cleaning up options, including imputation, various imputation like mean, median, mode, or even remove the entire column, or even use any custom substitution. But we discussed that unless the data, the number of rows of missing value is very high, we'll prefer to remove the entire row. That way, we have enough data and we are not replacing the missing values, only representative data. So in this case, we are going to remove the entire row. Now you must be thinking, what is this minimum and maximum? So every node will take only one action on the missing value. So in this particular case, the only action that can be taken is remove entire row. But I may want to put a guardrail. I want to say that if the number of missing values is too less or the number of missing values is too more or too high, in that case, do not replace, because in that case, probably that's not the right approach. So I can put an additional guardrail saying the minimum ratio of missing value or the maximum ratio of missing value for which this particular cleaning mode will be applicable. Now, in this particular case, we don't need to do that because we know that all of these missing values, these rows, we are going to anyway remove. So we don't need to change anything as the minimum and the maximum value ratio is concerned. But in some cases, you may need to change this. Rest of the things we'll leave it as is. And you see this orange or amber is removed. That means the node has been configured correctly. Now, at this stage, if I want to run this, I have to again configure and submit a job. Okay, that's the negative side of this kind of pipeline, because it is built like that, because otherwise it will not be able to work on such large data sets. Okay. So it doesn't run the draft, it creates a job every time and runs it. Now it will be a little bit cumbersome to run the job every time I create a new package. So what we are going to do, we are going to do it at the end after we have created all the all the components in the pipeline. So assuming that we don't do any other pre-processing and assuming that this is the data that we will go for, we will then split the data into training and testing. So we'll search for a component that will split the data. Let's search for split data. Okay. With experience, again, as I said, that you will get used to these components. We have got this component split data, and we'll use this node. Okay, this node is used for the purpose of production deployment. We'll discuss this when we come to the deployment part of it. But right now, we will use this left node, which is the clean data set. And this is a classification problem. So we need to split based on stratified sample. Because if you do it in random sample, then it's possible that in the training data set, one of the classes are not adequately represented. So we need to do stratified sample. And so we're saying the splitting mode is split the rows, and the training data set will consist of 70% of the data. The industry standard is 70 or 80% of the data goes to the training data set. And when you write this 0.7, it means that the first data set is going to create, it will have 70% of the data. But we cannot use randomized split because, as I said, in randomized split, it's possible that there will be a huge class imbalance there may be a class imbalance in the training data set as well as testing data set, which may hinder the proper learning process. So, and instead, we will say stratified split is true. But when you say stratified split, it basically means that the sample, the classes in the sample will have this approximately the same ratio as the classes in the population. So when you are splitting it, you have to define what is the criteria based on which you are going to distribute the classes. Okay, and obviously here the class is based on the income. So our stratified splitting column is income. Now here, unlike the previous case, I will not be able to get any auto suggest. Okay, why? Because I have not run the previous steps of the pipeline. And hence, this particular node does not have any input data. If I want to get the input data, I have to run up to this level, find out the input data, and then again input it here. But then again, that can be a cumbersome process. You have to do it every time. We know that the stratification will be based on income, so we can manually type it down. Only thing you have to remember that there cannot be any spelling mistake. In that case, it will give error. Okay, and also you have to remember that it is case sensitive. So if I write income with a capital I, wherein the data attribute is small I, it will also give an error. So we know the income is small I, and we'll just type it down and press enter, and hopefully it will work. Okay, so this is what we have done. Now, once you have split the data, we should get the training data set on the left-hand side once we submit the job, not now. Okay, and we need to select a model for which will be trained on the training data set. For now, let us select a type of decision tree. Okay, we know a random forest is a type of decision tree where you have many decision trees. The outcome is combined in certain format or certain logic, and then the final outcome is derived. So in our case, let us consider, so there is an inbuilt random forest which is called two-class boosted decision tree. If you want to know what exactly the two-class boosted decision tree does, there is documentation, and what is the algorithm for that, there is documentation that is available. But since it's not a machine learning course, I'm not getting into those details here. So we'll just go to two-class boosted decision tree. There are many two-class, so let's just say two-class boosted decision tree, and we'll put the model over here. Okay, this model will require some configuration. So for example, here we have the option of maximum number of leaves per tree and the maximum number of samples per leaf node. We know that if the minimum number of samples per leaf node is uh, you know reduce that number, there is a possibility of overfitment. Okay. And similarly, if you increase the maximum number of leaves per tree, there is the possibility of overfitment. Now, this is what is hyperparameter tuning. We don't know what is the most optimal solution, so you have to keep iterating and with try out with various values till the model gives you the best results. Now, that is obviously something that is very difficult to do manually. So this is where AutoML comes handy, because in AutoML, all these iterations are automatically done, and the model will finally, or the AutoML algorithm will finally give you the best model with the best tuned hyperparameters. For now, I will leave these as default values. There are other few things like learning rate and number of trees constructed, etc. We'll leave that as it is. Okay. So now this model needs to be trained. So we'll just use something called a train model. This train model, bring it over here. Now, one input of the train model will be the model itself, and the other input will be uh, the training data set. And we need to configure something. We need to tell the model that what is the label or what is the target. The target obviously is income. Again, we have to type it down. You have to be careful with the spelling. Model explanation is another very interesting feature of Azure, where uh, it gives you it explains how the model derived a particular classification. Today, explainability of a model is a very, very important thing. We call it XAI, explainable model, and Azure does that very well. But in this video, we are not going to do that. We're just building the model, so I'm leaving it as false. Once I do this, next thing is that I will I will test out this model on the test data set. Where is the test data set? The other node. So in order to test the model, I'll use a component called score model. Score model, you can see. So it will give me the output after testing the model on the test data set. We can check if there is any specific configuration that we need. We are saying append score columns to output. This basically means that we are going to also have the probability. We all know a classification problem is essentially a regression problem where the output actually is a probability, but then we apply a cutoff. Usually it is 0.5, and if it's more than 0.5, it belongs to one class, and if it's less than 0.5, it belongs to another class. And then finally, we need to get some evaluation metrics like confusion metrics, ROC curve, etc., to figure out how well the model has performed. So we'll use this evaluate model. So evaluate model is there. And we'll not use the other input, we'll use only this input. And our basic machine learning model is created. In the next video, what we are going to do is we are going to submit this model as a job, and the model will run, and it will give me the output and will analyze the output.